Okay, we're going to talk about section 8 and 9 today, where we're going to talk about graphing inequalities and systems of inequalities and something that's called linear programming, which is involving inequalities again. So we're going to talk about how to graph a linear inequality with two variables, just like we've been doing with the x's and the y's. We're going to be talking about what a system of inequalities is, and then we're going to talk about how to use a systems of inequalities to calculate maximums and minimums using linear programming. So what we're looking at here is an inequality is it's just in the form of ax plus by is less than c or greater than c or less than or equal to c or greater than or equal to c. So we're just looking at lines that we're going to be looking at the graphs of these lines. So the first step is to draw the graph. So we're going to pretend that it's an equality and determine what the slope is and what the y-intercept, and we're going to graph the line. Now here's where the inequalities are slightly different. If we look at this, we'll notice that we have less than or equal to, of course that's going to happen now. Okay, we have less than or equal to, greater than or equal to. So anytime it involves that, then the line is going to be a solid line. So the solid line is just saying that it includes the line. That's what the equal to means. If the symbol is just a less than symbol or a greater than symbol, then the line is going to be dashed. It's going to be dotted line. So we're going to graph the line just like we're used to, and then we're going to choose a point that is not on the line, and we're going to test to see if that point works. So we're going to look at the original inequality and see if the number that we're picking is true or false in that region. Okay, so here's an example. 2x plus y is less than 4. So we're going to go through and solve this problem for y so that we can graph it. So we're going to have y is less than 4 minus 2x. So when I graph this line, I end up with a line that has a y-intercept of 4 and a slope of -2. Now because the inequality is just less than, my line will be dotted. Okay, so here's what I have. Y-intercept is 4. I don't have a very good line here. Y-intercept is 4. It should be up a little bit more, so let's move that. Well, we'll do that later. Y-intercept is 4, and the slope is -2, so we're going down 2 over 1, and we have a dotted line because that tells us that it is less than, not less than or equal to. So what we have to do is pick any point that we want that's not on the line. So I could pick this point, I could pick this point, I could pick this point, but the easiest point to pick, if you have that option, is the origin 0, 0. So we're going to pick 0, 0 as our test point. And what we're going to do is we're going to plug 0 in for x and 0 in for y. So 2 times 0 is 0, plus 0 is 0, which is less than 4. So my question is 0 less than 4? And the answer is true. So that means that we want to shade on that side of the line where the 0 is located. So what this tells you is that any ordered pair on this side of the line will satisfy the equation of 2x plus y is less than 4. So let's just pick another point and say, let's say I pick this green point right here. And that green point is -3, +1. And if I substitute -3 and +1 in for x, I'm going to get 2 times -3 plus 1. So it's -6 plus 1 is -5. Is that less than 4? And the answer is yes, or true. So that's another point. So any point in that shaded region will satisfy the equation, and so all of those numbers are solutions. Okay, so now here's another one. Um, Again, I'm going to go through and sort of figure out where my x's and y intercepts are, and I'm going to graph my line. Notice this time, though, that the inequality is greater than or equal to, so when I graph it, it's a solid line this time. It's a solid line. Okay, again, I can pick any point that I want, any point on the graph that I want. But anytime you have the option to pick 0, 0, I would pick 0, 0 because it's easiest. So x equals 0, y equals 0, so we're going to plug 0 in for x, 0 in for y, and we get 0 in our problem. So we get 0 greater than equal to 3. So you're going to ask yourself the question, is 0 greater than 3? And the answer is false. And then you're going to say, is 0 equal to 3? And again, the answer is false. So since 0 is on the false side, we want to go to the opposite side of the line where 0 is not, and that's where we're shading our graph. So when you do an inequality, you have to shade. So your line is either going to be a dotted line or a solid line, and you're going to have to shade one side of the graph, depending on which side is the true part. All right, so with the system of inequality, then what we're going to do is we're going to do the same thing that we did before, but we're going to graph two lines. And we're going to graph each line, and we're going to determine the shading of each line. And then we're going to look to see where those shadings overlap. Okay, so we're going to graph each inequality. We're going to use the same method as before, so we're going to graph it and shade. And then we're going to look to see where the regions overlap in their shading. And the overlapped region is the solution to the problems. Okay, so here's our graph. Graph the solution set for these systems of equations. X minus y is greater than or equal to negative 2. Okay, so it says greater than or equal to. So that means that we're going to have a solid line. So, and the other one says greater than or equal to also. So again, it's a solid line. So for this equation, if I think of it in the format y is less than or equal to 1 minus x, my y-intercept is 1, and my slope is negative 1. So I'm going to go down 1 to the right 1. So solid line represents the second equation. I pick a point that's not on the line. So I'm going to pick, again, 0, 0, because it's the easiest one to pick. 0 plus 0 is less than or equal to 1. Is 0 less than or equal to 1? And the answer is true. So we shade to the left of that line. Okay. Now we're going to graph our other line. Do the same thing. Y-intercept, so we're going to end up with y is greater than or equal to, I'm sorry. Okay, so we're going to end up with a y-intercept of 2 and a slope of 1. So we're going up 1 over 1, and we graph our line. Again, it's a solid line because of the inequality being greater than or equal to. So we end up with this line that's coming right through here. Now we're going to pick a point that's not on the line. And again, 0, 0 is not on that line that we just drew. Here's the line again that we just drew. 0, 0 is not on that line. So we're going to substitute in 0 and 0. And we're going to ask, is 0 greater than or equal to negative 2? So 0 is greater than negative 2 is a true statement. So we're going to shade on that side of the line where the 0 is. So if you look at my lines, you'll notice that where they overlap is right in this region right here. So this region where they overlap is the solution to the problem. So everything in this region right here would be a solution. So that what that means is that if I pick any point in that green region, it will solve both problems individually. So if I pick this point right here, which is -1, -1, if I substitute that into the first problem, -1, I don't want to make that confusing, let me try it again. -1 minus -1 is -1 plus 1, which is 0. Is 0 greater than -2? Yes. Now take it in the second equation. -1 plus -1. -1 plus -1 is -2. Is that less than or equal to 1? And the answer is yes. So again, what we found is that any point in that green region is a solution to both problems. So again, that's what we're saying here, is that the overlapping region is the solution to the problem. And again, any point in that area will be a solution to both equations. So what we have here is a process called linear programming. And linear programming is actually used to find either the maximum or minimum when we're talking about costs and profits and things like that in companies. And it uses this concept of graphing inequalities and systems of inequalities to solve our problems. So what we have to do is read the problem very carefully and look for some information. So what we're going to look for are things called constraints, and those are all of the restrictions on our problems. And we just have to read the problem very carefully and write it down as we read it. We're going to graph all of our constraints, and we're going to shade all of our constraints. And then we're going to look to see where everything intersects and figure out a solution based on that. Okay, so this is going to get a little bit long, so let's look at what we've got here. A company makes DVD players and MP3 players. Each DVD player gives a profit of $3. So you might want to underline that because we're talking about profit of $3. And each MP3 player gives a profit of $7. So that's sort of important for the next step. The company must manufacture at least one DVD. So this is a very important thing. At least one DVD player, but no more than 5 DVD players. So at least means greater than or equal to 1. No more than means less than or equal to 5. Okay, the number of MP3 players must be more than the number of DVD players. So the number of MP3 players has to be greater than the number of DVD players, but it can't exceed 6. So it has to be less than or equal to 6. And then how many of each should the company make? So let's read all this again. X is the number of DVD players, and Y is the number of MP3 players. It doesn't matter which one is which, but this is how we're setting it up for this one. You could have switched it and it would still give you the same answer. Okay, so X is DVD players. The number of DVD players must be greater than or equal to 1, and the number of DVD players must be less than or equal to 5. Remember what it said, the company must manufacture at least one DVD player, but no more than 5 each day. Okay? Y is the number of MP3 players. The number of MP3 players cannot exceed 6 each day. So it has to be less than or equal to 6. But the number of DVD players and MP3 players, it says the number of MP3 players must be more than the number of DVD players. So MP3s are greater than DVDs. Now, you can't have a negative number of either of these. You can't manufacture a negative number. You could manufacture 0, but you can't manufacture a negative number. So the number of MP3 players has to be bigger than 0, and the number of DVD players has to be bigger than 0. Okay, so now we're going to graph all of these restraints. The first one, X is greater than or equal to 1. It's a solid line right here at x equals 1. Sorry, I can't draw very straight. X must be less than or equal to 5. Okay, is a solid line right over here at 5. Now notice these are both solid lines. Okay, so x is greater than 1. So if I pick the number 0, because 0 is to the left of 1, 0 is greater than or equal to 1 is a false statement. So that's why we shaded to the right. X is less than or equal to 5. Again, here's our line. We picked 0 again. 0 is less than or equal to 5. And that is a true statement, so we shaded to the left. So currently, what you're not seeing is that we have the first line, and we have everything shaded to the right. And then we have the other line, and we have everything shaded to the left. And so right now they're overlapping in the middle of these two lines. So let's continue with our constraints. Y is less than or equal to 6. So here's where y is 6. And so if we pick 0 again, 0 is less than or equal to 6 is true. So here's that other line that's come through there, and we're shading down here. So now you see where they're overlapping is right here in this rectangular area here. Our last one is x is less than or equal to y. So we have a line that's coming right through here, x equals y. Here's that line right there. Just coming right through here. Now, unfortunately here, I can't pick 0, 0. Because if I pick 0, 0, the line is going through 0, 0. So I'm going to pick this point right here, which is 0, 1. So 0 is x and 1 is y. 0 is less than 1 is true. So I'm shading above that line. So what you'll notice is that right here in this region, this is the area where all of those lines, all of that information is overlapping. And so when we look at this picture again, let's go back to what we had originally. What you're seeing here is just the overlapped region. So it's called the region of feasible solutions. So these are all the possible solutions. Now the x is greater than 0 and y is greater than 0, we didn't worry about it because we were limiting it even more with the x is greater than 1 and x is less than 5. So we didn't worry about that. So here's our region. Now what we want to do is look at these corners. We're looking at what these vertices are right here in the corners, because what it's proven is that one of those 4 vertices is going to represent the maximum or minimum, whatever we're trying to find. So now we're going to look at the profit information, and it says that they get $3 for every DVD and $7 for every MP3. So 3 times x plus 7 times y. And what we're going to do is we're going to figure out what the optimum amount is. So we have a chart here, and we took each of those 4 vertices. Let's go back a second, I'll show you what I'm talking about. We took the vertice 1, 6, 5, 6, 5, 5, and 1, 1, and we used those in our chart. So that means what we have here is x equals 1 and y equals 1. And we plug those into our formula, and then x equals 1 and y equals 6. Plug it in for x and y. X equals 5, y equals 6, plugged it in. X equals 5, y equals 5, plugged it in. So this number tells us what our profit is. We have $10 profit if we produce 1 MP3 player and 1 DVD player. We have $45 profit if we produce 1 DVD player and 6 MP3 players. We have $57 profit if we produce 5 DVD players and 6 MP3 players. and we have $50 profit if we produce 5 of each. So the maximum profit would be $57, and that's when I created 5 DVDs and 6 MP3s. So what we've done is maximized our profits, and what this tells us is that no matter what points we pick on that graph, this represents the largest income we can make. So businesses will use this, knowing some of our constraints, they'll use this to figure out how many things to ship or how many things to produce in order to maximize our profits. Okay, so let's look at another one. A manufacturer of refrigerators must ship at least 100 refrigerators. So at least means they can ship more than 100, but if they don't ship 100, they're going to have problems. And they have two warehouses that they can ship it to. Each warehouse holds a maximum of 100 refrigerators. Okay, so warehouse A holds 25. I'm sorry, warehouse A currently holds 25. So that means they can take 75 more. Because they have a capacity of 100. They've already got 25, so 100 minus 25 is 75 more. Warehouse B has 20 already on hand, so they can take 80 more. It costs $12 to ship the refrigerator to warehouse A and $10 to ship it to warehouse B. So what we're talking about here are costs, which is going to come in our second step. Okay, so let's talk about this. So X is the number of refrigerators that we're going to send to A, and Y is the number of refrigerators we're going to send to B. So that means X and Y both have to be bigger than 0. They cannot equal 0 because I've got to ship some refrigerators to A and some refrigerators to B. X has to be less than or equal to 75. Remember what we talked about. Warehouse A can only hold 100 refrigerators, and they've already got 25 on board. So that means they can only take 75 more. So it has to be some number less than 75. And warehouse B can only accept up to 80. But the number of refrigerators that I ship to A and B has to be 100 at least. So it has to be some number bigger than or equal to 100. All right, so we're going to graph these lines. So here we have again, X equals 0, Y equals 0 are my axes. So here's my Y equals 0 line, here's my X equals 0 line, and technically, and I just did this wrong, technically those two lines should be dotted lines. So this one's a dotted line, and this one's a dotted line. Okay, and right now, because we're greater than, to the right, we've got this whole first quadrant shaded. So currently, what our graph looks like is all of this region is shaded here to the right. And now X is less than or equal to 75. X is less than or equal to 75 is this line right here. And less than or equal to 75 would be this area to the left of that line. So we're looking at shading over here. So we're now restricted between the y-axis and the blue line. Then I have y is greater than, or sorry, less than or equal to 80. So that's this line right here. Less than that would be below. So again, if we look at our little diagram over here, we're talking about shading below this. So now we're looking at that square in the middle. And then our last one is X plus Y is greater than or equal to 100. So that's this line that's coming through here. Now when I do greater than or equal to 100, if I pick 0, 0 plus 0 is greater than 100 is a false statement. So this time I'm shading over here. So this area, this triangular region right here is our feasible region. And so I'm going to pick my vertices on that feasible region, and I get these 3 vertices. So now I'm going to test those three vertices with my with my cost margin. So it costs $12 to ship to warehouse A and $10 to ship to warehouse B. So testing each of my points, if I put in 2080, I get a cost of 1,040. If I put in 7525, I get a cost of 1,150. And if I put in 75 and 80, I get a cost of 1,700. So, of course, with cost, we want the minimum cost. We don't want to spend as much. So the minimum cost is going to be $1,040 when I ship 20 to warehouse A and 80 to warehouse B. So now a company would know that it's going to be cheaper for them to ship to warehouse B, and they would end up, as long as all the refrigerators are selling, getting a higher profit, a lower cost if they do that shipping arrangement. I hope this is helping. This is our last section for the information. Your test is coming up. Make sure you keep in touch with me about any problems you're having, and have a great week.